Okay, you're here with me because you want to listen to the reading about what happens when fuels burn. I'm going to give you some examples of some annotations that that come to mind when I read this, and maybe some words that I think are pretty difficult to understand. So this won't be perfect, but I'm going to work through it the way that I would work through it. We'll listen to the reading. So let's start.
What happens when fuels burn? Most people burn fuels every single day. Fuels are substances that release energy when they burn. They are very important to us because we use the energy from burning fuels to do many things, such as run cars and buses, heat homes, and cook food. For example, gasoline is the fuel used in most car engines. When it burns, the energy it releases makes the car move. To prepare for a long trip, you fill your gas tank with gasoline. But after you drive for a while, the tank is empty and you need to fill it up again. What happened to the gasoline? Where did it go?
Okay, so I'm going to annotate the question that they bring up right here. What happens to the gasoline? I'm going to highlight that and I'm going to add a note that gasoline is made of atoms. Can atoms disappear? Okay, so I'm going to save that. While I read this, I'm thinking to myself, it's true that if I use gasoline in a car to make it, to get the energy from the gasoline, the fuel, do the atoms disappear or do they go somewhere else? That's a question that I would have from what I just highlighted. So you're more than welcome to annotate that if you'd like, or you can annotate anything else in that first paragraph that you thought was interesting or a connection you can make to your own life. Okay, we're going to look at the picture real quickly. And I'm going to read the caption. When you burn wood in a fireplace, the wood is the fuel that keeps the fire going. Cars are powered by fire inside their engines. Gasoline in the fuel helps those fires burning. Okay, a commonality, and I'm just going to click in the middle here. Something that I see that's kind of common between wood burning and it said gasoline needs to burn is that maybe to release energy, you need to burn things. So I'm going to just annotate that. And you're more than welcome to pause at any point that you want. Okay, we're going to go on.
When we burn something, whether it is a log, a match, or the gasoline in our gas tank, what we are actually doing is causing a chemical reaction. Burning gasoline may not seem like the kinds of chemical reactions that you have seen before. After all, chemical reactions cause substances to change into other substances as the atoms of the reactants rearrange to form the products. When gasoline burns, it doesn't seem to change into a different substance. Instead, it seems to disappear, leaving you with an empty tank. If burning gasoline actually causes a chemical reaction to happen, then why doesn't your tank fill up with a different substance? Can a chemical reaction cause something to change into nothing?
Okay, I'm going to think about the video that I watched of the paper burning. And what I saw in that picture was I saw that there was a gas that was released. So right here, if it's the man who's reading said if burning gasoline actually causes a chemical reaction to happen, then why doesn't your tank fill up with another substance or a different substance? I'm going to highlight that and add a note that maybe there's a gas that forms that we can't see. If it's a gas, we know that gases are made of molecules and molecules are made of atoms, but they could escape and go out into the air possibly. So I'm going to save that.
Scientists began to wonder about this question back in the 1700s. Around this time, a French scientist named Antoine Lavoisier began studying what happened to the masses of substances before and after a chemical reaction. Mass is a measure of how much matter makes up an object.
Okay, I'm going to quickly just highlight that because I think that's probably going to be and I'm going to do this in a different color. Okay, I think that's an important word to probably remember.
First, Lavoisier measured the mass of two reactants before mixing them to cause a chemical reaction. After the reaction had happened, he measured the mass of the products. Every time, Lavoisier found that the reactants and the products had the same mass. Through these experiments, Lavoisier helped come up with the idea we now call the law of conservation of matter. Matter cannot be created or destroyed during chemical reactions.
Okay, I am going to highlight this. This seems like it's pretty important. Sounds a lot like a law that we learned earlier this year called the law of conservation of energy. And I'm going to add a note that what I think this is saying is in a chemical reaction, all of the atoms that rearrange are still there. They don't disappear or get created. They just rearrange to form new substances. Okay, and remember that's a lot to type, and I did that pretty quickly. But you can pause so that you can get this written down if you'd like to.
This is because the atoms that make up all matter cannot be created or destroyed during chemical reactions. This law tells us that all of the atoms that go into a chemical reaction must come out in the form of one substance or another.
Okay, and I think right here, again, this tells us that when we have an empty gas can or an empty gas tank, all of those atoms had to go somewhere. Okay, so my question would be, what are these substances? Okay, so if I know that when a gas tank is empty, those atoms got rearranged into a new substance, my question would be, what are those substances that the gasoline turns into?
Chemical reactions cause atoms to rearrange into new and different groups, but the atoms themselves never stop existing, and new atoms never appear out of nowhere.
Okay, and I'm going to highlight this because to me, if it says that new atoms never appear out of nowhere, my question would be, so there are the same amount of atoms Okay, so are there the same amount of atoms in the universe that there have always been? Kind of like energy. We talked about the law of conservation of energy, that you can't create or destroy energy. Sounds like you can't create or destroy atoms either. So that means in the universe, there's always the same amount of energy, but there's also the same amount of atoms or matter.
So what does the law of conservation of matter have to do with burning gasoline? It means that even though your gas tank is empty, the atoms that form the gasoline must still exist somewhere in some form. The only reason that these atoms seem to disappear is because the substances that form when gasoline burns are invisible gases. You can't see them, but they are there, and sometimes that isn't a good thing.
Okay, so I'm going to, again, now we know that they're invisible gases. My question would be, what I should say, substances are these gases?
Carbon-containing fuels. Gasoline is just one of many fuels that contain carbon. One of the most common fuels in use today is ethanol, a substance made up of groups of 2 carbon atoms, 6 hydrogen atoms, and 1 oxygen atom. Ethanol is made from corn and used as a substitute for gasoline. Like gasoline, ethanol is a colorless liquid at room temperature. When you burn anything, including ethanol, you are mixing it with oxygen. However, just having oxygen around isn't enough to make something burn. This reaction only happens at a high temperature. Burning reactions release energy in the forms of heat and light, but these chemical reactions result in more than just energy. See the diagram below to learn more.
Okay, right here, burning reactions release energy in the form of heat and light. I'm going to highlight this. Should probably highlight the whole thing, because my question would be here, my car wants to move. It doesn't want to not give off much light or get hot. And that's just something I'm thinking about. Like, okay, if that's what burning reactions do, okay, how do I get my movement out of my car if it produces mostly heat and light? All right, then I want to take a look at the burning ethanol at an atomic scale. So I can see that ethanol has to be added to oxygen. So you can see this is what they're talking about with a carbon. It's a carbon substance. And what happens if you look at this is the 2 carbons each come together with 2 oxygens to make what's called CO2, which is carbon dioxide. And you also form water molecules. So I know a few things about global warming and the ideas behind that. Carbon dioxide is something that's building up in our atmosphere, probably because of the use of cars and other machines. I'm not going to annotate that, but I'm just going to talk you through that. Okay, I'm going to listen to the rest of this with you, and if you want to stop, you can stop to annotate, but I'm not going to annotate anymore. I'm just going to listen with you.
The chemical reaction that happens when ethanol and oxygen mix produces 2 substances, carbon dioxide and water in the gas phase. Since both of these are invisible, colorless gases, it seems like nothing is left of the liquid that was in your gas tank. However, the atoms of the reactants haven't disappeared at all. They've only rearranged to form the products. The carbon dioxide and water produced by this chemical reaction enter the atmosphere whenever we burn ethanol or other carbon-containing fuels. In the recent past, humans have increased the amount of carbon dioxide in Earth's atmosphere by burning such fuels, resulting in widespread changes to Earth's climate. In response to these effects, scientists are working to find fuels that can release energy without producing carbon dioxide. Hydrogen fuel. Like gasoline, hydrogen is a fuel that can be burned to power cars and buses. However, unlike gasoline, hydrogen does not contain carbon. It is a substance made up of hydrogen atoms. When you burn anything, including hydrogen fuel, you are mixing it with oxygen. Still, Having oxygen around won't cause something to burn on its own. This reaction only happens at a high temperature. Fires are hot and bright because burning reactions release energy, but energy is not the only result of these chemical reactions. See the diagram below to learn more.
So just thinking real quickly about using hydrogen as fuel instead of gasoline or ethanol, the only product of burning hydrogen and adding oxygen to that hydrogen is water. So when I think about that in my own mind, that seems like it wouldn't be so bad for the environment if we used hydrogen fuel in our cars and things like that, because we would only end up with water coming out of our tailpipes, not water and carbon dioxide.
The chemical reaction that happens when hydrogen and oxygen mix produces only one substance, water in the gas phase. Since this is an invisible, colorless gas, you can't see it, which makes it seem like nothing is left behind by burning hydrogen fuel. However, the atoms of the reactants haven't disappeared at all. They've only rearranged to form the product. The water produced by this chemical reaction enters the atmosphere whenever we burn hydrogen. Still, compared to the carbon dioxide that is produced when we burn gasoline, ethanol, and other carbon-containing fuels, the water produced by burning hydrogen has a less harmful effect on Earth's climate. If we can power our cars with hydrogen without producing carbon dioxide, then why don't more vehicles use hydrogen fuel? Unfortunately, the technology needed to use hydrogen as a fuel is expensive, and storing hydrogen fuel can be difficult. Also, the most common way of getting pure hydrogen is by separating it from substances that contain carbon. So although burning hydrogen fuel does less harm to Earth's climate than burning carbon-containing fuels, the production of hydrogen fuel is still a problem for scientists trying to reduce climate change.
Okay, thank you for listening. I'd like you to go on to lesson or activity 4, and I'd like you to watch the videos so that you know where you can post some of your thoughts or questions.